3.1 Part B. So determine whether each number is a solution to the given inequality. We started that yesterday. We just need to see if we plug that -5, for example, in, does that work to make our inequality true? Well, 2 times -5 is -10. Is -10 less than 10? Yes. So this is a solution because -10 is less than 10, so -5 does work. So 2 times 1, is that less than 10? 2 is less than 10, so this also is a solution. And the third one, 2 times 6, is that less than 10? 12 is not less than 10, so not a solution. All right, so let's talk about graphing our inequalities. They're not that hard to graph. So if this was x is less than 2, I would graph it by starting to find 2. And I only want things less than that. So all of these numbers are less than. And you notice I did not color in that dot at 2 because it doesn't say equals to 2. So I can't color in 2. I have to leave an open circle for is less than. So open circle at 2 and then pointing to the left. All right, then we have x is less than or equal to 2. This one has the or equals to, so I can color it in. So it's a solid dot at 2, and then again, we're pointing to the left because it's less than. Greater than 2, x is greater than 2. Again, it doesn't have or equals to, so we have an open dot at 2, and all those numbers greater than it point to the right. And x greater than or equal to 2. Here's our filled in dot pointing to the right. Sorry, I'm trying to get it filled in, but it won't let me. All right, you can use the number lines to show all of the solutions. So if you look at this, let's do a few. N is less than 1. So here's a 1. Again, open circle because it's not or equals to, it's just less than, because it's not 1, it's less than 1. So less than points this way. A greater than or equal to 0. It can be 0, or it can be any number larger than 0. F greater than -3. It can't be -3, but it can be any number larger than -3. So that's why we have the open circle, because it can't be -3. This one, a lot of times people like to flip it around. So x, if you notice here, the smaller point or the single point is towards x, so it still has to be if you flip it around. And -2. So this reads as -2 is greater than or equal to x, or you can read it as this one, x is less than or equal to -2. So here's -2 and it has or equals to, so I'm going to fill it in. X is less than that. So it's all numbers less than -2. All right, you could to try these two and we'll check it with your notes. So if we have a graph and now we have to go backwards and write the inequality, first thing I do is I look, is it filled in? Yes. So the dot is filled in at -1 and I want numbers greater than -1. So x greater than or equals to, because it's filled in, -1. So we look at the next one. This one, it's an open circle, so I'm not going to have or equals to, and it's 4, and it points to the left, so less than 4. When you write this, if you notice this statement, you see that this less than actually points the same way as that arrow when the X is on the left. So some kids, if they get confused which direction to point or how to write it, the arrow points to the left, and if you look at this, it looks kind of like an arrowhead and it points to the left. So go ahead and do these two and we'll check it with your notes. So we're going to define a variable and write an inequality to model each situation. So these are real world situations. If this is true, a person must be at least 35 years old to be elected president of the United States. So if we wanted to break that down to just a math statement, I'm going to call P, let P be person, sorry, PE. Then if I want to talk about how old they need to be president, I know that P, I should call it person's age actually, that P has to be at least 35. So it can be 35, but it has to be at least 35, so it would be like 36, 37, 38. So that would be greater than or equal to 35. And if we look at this, a law clerk earned more than $20,000 since being hired. So let C equal clerk's salary. Law clerk earned more than $20,000. Well, there's my $20,000 and my C. It has to be more than $20,000. So C is greater than 20,000. So you are going to try to do the next one. We're going to do this last one together. So you should do at least 475 students attended an orchestra concert. But let's look at this one. You need at least $15 to go to the movie and get a snack. So I need at least $15. So I need at least, so something greater than $15 or equal to $15 to go to the movie and get a snack. I already have $8. So I'm going to have, so let N equals amount still needed. I already have $8. So whatever I have plus, excuse me, whatever I need plus $8 has to be greater than or equal to 15. So I'm going to say N plus $8 has to be greater than or equal to 15. So I don't still need 15. And if we're going to actually solve this, we could subtract 8. And we would say I still need at least $7. But we're actually just supposed to write this. So this would be our end spot here. We would just be able to write that inequality. Which inequality has the same solution as K is greater than 6? Well, this one, K is less than negative 6. If I do this, here's 0, here's 6. I want them to be greater than 6. Open circle, right? And this one says K is less than negative 6. Well, it's going to be 0, negative 6. Less than that does not look the same. How about this one? Here's 0, there's my 6. K, this is 6 is smaller than K. Or you can rewrite it, K, keep the same side of the inequality facing K. So I have the 2 dots, I still have the 2 dots. So K is greater than 6. So that is the one that we want, right? This, K is greater than 6, is the same, or 6 is less than K is the same. That is it for this lesson.